Sets and Venn diagrams. Like I said, this is going to be from chapter 2 of the red textbook, and that's why the homework assignment, if you look at it on Blackboard, is kind of all over the world. That's because I pulled questions from several different sections of chapter 2 in the red textbook. Sets and Venn diagrams. Well, first thing we need to talk about is set notation, and we need to know what the universal set or the sample space U is. Typically, I just say your universe. So the universal set is represented by a rectangle, and a set within the universal set is usually represented by a circle, and anything that is in the universe can be called a subset of the universe, or any set that is inside another set is called a subset. Now, set A is everything in the circle, where A prime, or the complement of A, as you would say it, I like to say A prime, is everything else that is in the universal set U, but not in A. What's really, really, really important concept is that A prime plus A gives you 1. It's kind of like what we talked about yesterday when we were doing the probabilities. I mean, basically, something either happens or it doesn't. And the probability that something happens plus the probability that something doesn't happen had better equal 1, because something either happens or it doesn't. So that's what this is saying right here. It's saying, yeah, the probability of picking something from set A plus the probability of picking something from not in set A equals 1. Should be pretty easy. Some more symbols and things we need to understand. We're talking about set notation. This little symbol right here means element of. So it says X is an element of set A, meaning little x would be something that is in A. N of A means the number of elements in set A, and I hit on that yesterday. Just like P of A means the probability that A happens, right? This is called a cap. A cap B means intersection. So A intersect B is the thing that exists in both A and B. So all the stuff that exists in A and B, we would use the intersection for. And over there in that Venn diagram, it's shaded in pink. It's where the circles overlap. A and B. This is called a cup. So it's cap and cup. The cup means union. And we've seen unions before when we're doing interval notation and things like that, because it's stringing together sets. So A union B is the union of sets A and B, and this is things that are in A or B or both. That's how that works out. So if it's in A or in B or in both, it is in A union B. Now, if the sets never overlap, if it's impossible for something to be in A and B at the same time, then what we would say is that these two sets are disjoint. They have absolutely nothing in common. So if I said, what is A intersect B, you wouldn't say 0. You wouldn't say 0, because that would imply that the number 0 is in A and B. If A and B never intersect, what you use is this symbol, and this is the empty set. And it doesn't matter which way you draw the line. You see my line went the other direction from what was typed. Not a big deal, though, okay? That is the empty set. Ooh, I said disjoint, didn't I? Yeah, we're good. I'm good. We're good. I said it right. It's another term for disjoint is mutually exclusive. They never, never overlap. You need your notes. So disjoint and mutually exclusive mean the exact same thing. 0 things exist in both. Like the possibility that today is both Monday and Tuesday at the same time. Impossible. It's because the set of all the time in Monday and the set of all the time in Tuesday are disjoint. They are mutually exclusive. There is no time that overlaps. Good with those ideas? Yay!
That would be so weird.
It would be weird. On separate Venn diagrams containing 2 events A and B that intersect, we're going to shade the region that represents what's being described. So yeah, we're just practicing creating Venn diagrams. It's part A, and it said sets A and B do intersect. So here's A, here's B, just put a little A and B like so. We have to shade everything that is in A but not in B. shading everything that is in A but not in B. That means that you would go ahead and start shading circle A, just avoiding any parts of circle B. So here's all the stuff that is in A that is not in B. Just avoid the overlap.
Are they always going to make us draw this?
You don't have to draw it unless the directions say to.
So why are we doing this?
Because the directions say to. Very simple question.
Oh, yeah.
Yeah. For part B, draw the same Venn diagram. I think I can cheat a little bit. Let's see. I'm going to cheat. Come on. Whoops. I'm cheating. I'm cheating. I'm using the tools that are available to me. It would not surprise me if an IB student were to cheat.
Oh, you cheater.
Like I said, I'm cheating. Anyway, just a second ago I had this shaded. So this is all the stuff that is in A that is not in B. Now the next one says, no, the rectangle represents U. The rectangle is the universal set. So if you draw a rectangle, it's automatically assumed, oh, that is everything in the universe. Yeah, they were just showing you that the universal set is represented with a U. For this next one, we have to shade things that are neither in A nor B. That means you cannot shade circle A or circle B. Well, no, there is something to shade. Then you shade outside.
Oh, that's some tricky stuff.
No, it's not.
That's like when they tell you to think outside the box, but literally you shade outside the circle.
No, this is thinking inside the box, outside the circles. Good try, though. There. That represents, so if I said, describe all the students that are in the school but not in my class. Okay?
And what would A and B be?
A and B would be good students and students I like, and B would be, or no, and then the rest of the universal set would be my class. Got him, got him. I'm kidding, yeah. No, B, no, I said things I like and good students. You're neither of those, Gavin. So, got him again. Now, all right, so look, it is important that you also be able to label these with other names. As far as I'm concerned, you should be able to see this and be able to name it as other objects. First of all, it says in A but not in B. So what does that look like in set notation? I want you to be able to do this. So how else can I label this? This is where the thing that's, right now the thing that is shaded, hey, I'm trying to help you not fail. I just told you it's one of the hardest units in the book. Please. You guys remember Stonehouse and Stoss and all that? You guys remember them? Yeah. Why don't you text them and ask them about probability? Okay? Some of the smartest students we've ever had come through the IB program crap themselves in probability. It's hard. Okay? So here's what I want to do. I want to give this other names. Or first of all, I want to name it the way they said it. Maybe that's what I want to do. Using set notation. How do I describe this shaded region in set notation? The shaded region is where A intersects everything that is not B. That is what's shaded. See, it says A but not B. That's like saying A and not B at the same time. So A and not B. Think of the intersection as meaning and. Think of the union as meaning or. Yes? B prime because I did not shade anything that was in B. If I said shade everything that is not B, then you would have shaded this. This is everything that is not B. Correct? So everything that is not B, where does it overlap with things that are in A? Right there. So this is the intersection of things that are in A and the things that are not in B. Make sense? She says no. Why can't I just say what? Why can't I just say B? Because B is not shaded.
It's okay, I'm just as confused as you are.
See, wouldn't it be great if everybody was quiet and understood? Let's try again.
Would it be great if Trump got reelected?
Shut up, shut up.
See, Gavin, you're like part of the biggest problem, dude. Okay, how about this? Let's try again. Where'd that picture go that I just told it to paste? Why didn't it paste it like I said to?
I completely understand what you did, I just don't understand why it's B prime and not B.
Okay, could just wait just a moment, please. I gotta shut everybody up. See, there's no point in me explaining anything with this many voices in the room. Mine should be the only voice in the room right now. We start over with several Venn diagrams, okay? Here's A, here's B. Okay. For this one, for this first one, here's what we're going to do. We're going to shade A and A only. And I'm going to shade it in blue because that's the color I used. You know what? I wonder if I can use the paint bucket. Fingers crossed. Shucks, almost. Dang. How can I make it see that region separate? I don't think I can. Now let's see if I can make that work. I'm gonna have to use my mouse. There. Okay, there's only A. Cool? Here is, ooh. Here is everything that is not B. Fingers crossed. Jackpot. That's not everything that's not B. That's also not B. Does that make sense?
Yeah.
Okay. Hold on. B prime means not B. Great. Now, over here, we're going to do everything that A, oh God, again. Everything that A has in common with B prime. Comfortable? Ready for this? Magic. The overlapping stuff should have turned purple. That's why I wrote it in purple. And that purple stuff was there and there. Did you see it?
Wait a minute.
Yeah, sorry. There. That was the only part that was both blue and red at the same time. So once again, you hit undo, undo. The only part that is blue and red exists. You know what I'll do? I'll copy paste.
That's showing.
So the only place, and you can see this, you can see the outline looks like a beige C. That is this. Whoops, that is the stuff that is both blue and red at the same time, which is why I could call it purple. So that is where A intersects with B not. Better that way? Neither A nor B would be just. So this is, yeah, A prime union B prime would be a way of describing this.
Okay.
Because it's where everything that is not A is put together with everything that is not B.
Okay.
No, that's not A not. No, I'm sorry, I misspoke. You'll see. Don't worry about it, okay? You're going to confuse people. But is this better? We're better seeing it with the colors and all that stuff? Great. Let's see what else we can pull off, okay? I would like to also name this one on the bottom right because I think it's important that you be able to do this. This is everything that is both in, which means overlapping. And overlapping means intersection. This is everything that is in A naught and B naught at the same time. So this one is where A naught intersects B naught. The union of A naught and B naught would include, the union would also include this and, oh gosh. Okay, well, it must not have been as good as the one I had on the panel over there a moment ago. But the union would have included this and this as well. It would have been everything except for the intersection. Okay? But that's a good way of naming it. And by the way, it's not the only way of naming it. It's just all I'm going to show you for now because I don't want any brains to explode. We're comfortable with this? Or one more name for this one on the bottom right because it's low-hanging fruit, so it's easy to grab. Would be this. A union B means put the two circles together, right? That means take everything that's not in either circle. These mean the same thing. It's just important that you start thinking this way. And I'm not going to lie, probability with set notation and stuff like that is not always easy. Set theory is hard. Set theory is very difficult. And this is just baby steps. A prime union B prime would also include this and this. That's A prime union B prime. Yes, it includes everything that's not in B, everything that's not in A. So it would fill in those partial moons as well. Right, exactly. So there's other ways of naming this one on the left, but they're just hideouser. That's not a word, but it is now. But anyway, that's how we would do that kind of thing. Okay.
Okay, that makes sense.
Now for this one, rather than coloring them in, this one's not set theory. This one is just creating a Venn diagram and basically drawing it and then answering the question. So it says, suppose set A is the set of all the factors of the number 24. Oh boy, there's a bunch of them. Well, first of all, A is the set, and so we use braces to describe a set. And you see over here, they told you that the universal set, I'll read this to you in just a second, what that says. But I'm going to list all the things in set A. We always use braces to describe a set. 1, 2, 3, 4, 6, 8, 12, and what else? 6, 8, 12, is it 24? Yep, there you go. Those are all the numbers that are factors of the number 24. So what does that garbage over there say after U? It says the universal set is the set of all x's, and this means x is any element in U, the set of all x's, and that straight up and down line is read as such that. So the universal set is the set of all x's such that x is between 1 and 28 inclusive. Oh, and by the way, x is an element of the integers. That's what that z means. That's the integers. So that says, did you not hear the things I said? Do I need to repeat it?
No, I did, but I don't understand how we went from what we did yesterday to this. I just don't see how that connected at all.
Okay, so anyway, now that we have all the factors of 28 written out, now 24, what am I doing? These are factors of 28, not just, no, oh, okay, and then B is the set of all the factors of 28. Factors of 28, 1, 2, 4, 7, 14, 28. Much smaller set. You know what I'm going to do? I'm going to make the Venn diagram first. I know that it doesn't tell me. I know it says to do that second, but I'm going to do it first. Venn diagram. What are we confused about? What's confusing about this? those numbers in set A are the numbers that you could divide 24 by, and the numbers in set B are the numbers you can divide 28 by. I'm going to put them on a Venn diagram now. And anything that exists in both will go in the center. So numbers that exist in both. 1, 2, 4. Is that it? Yeah. Those numbers exist in both. 1, 2, 4. Now, the numbers that exist in A but not B, 3, 6, 8, 12, 24. The numbers in B that are not in A, 7, 14, 28. This Venn diagram is not finished, because our universal set is every integer between 1 and 28. That means we're missing a bunch of them. So 1, 2, 3, 4, 5 isn't anywhere, so 5, squeeze a 5 somewhere. 6 is in one of them, 7 is in one of them, 8 is in one of them, but 9, 10, and 11 are not. 9, 10, 11. 12, yes. 13, no. 14, yes. And then 15 through 24 is a big fat no. So 15, 16, wherever you can squeeze them in, 17, 18, 19, 20, 21, 22, 23, 24. My Venn diagram's not large enough. Oh, no, sorry. I said between, and then I wrote it. Sorry. But 25, 26, and 27. 25, 26. Come on, squeeze me in there. Suck it in, 27. There you go. Our universe now contains all of the integers between 1 and 28. Set A is all the numbers that are factors of A. Set B is all the factors of 28. I think I said set A is all the numbers that are factors of 24. There we go. So part B is complete. We've done B. Here's B. Yay, B. Now let's do A. It says find A intersect B. A intersect B is a set. Oh, A is the left circle. B is the right circle. The set of numbers that are in both are 1, 2, 4. And then part C, A union B is, and by the well, is all the numbers that are in A or B or both. And you should write them in order. So this is a larger set. 1, 2, 3, 4, 6, 7, 8, 12, 14, 24, 28. It's in either circle. If it's in either circle, then it's in the union. Anybody know anything about writing checks? Do you know the difference between when a check says Mr. and Mrs. or if it says Mrs. or Mr. or Mrs.? Do you know the difference? So let's say my wife and I have checks and it says Mr. and Mrs. McCutcheon. That means if I take that to the bank and try to cash it, they're going to ask me where my wife is, because it says you and she need to be here for this check. It's the intersection. Both. If it says or, either one of us or both could cash that check. That's the difference. So if you look at your parents' checks, more than likely it'll say Mr. or Mrs. Or it won't even have a word. It'll just have their two names. That's how you avoid it completely. This one's finished. I think creating the Venn diagram made it easier, but that's just me.
Yeah, it made it a lot easier to do it first.
All right, so this Venn diagram illustrates the number of people in a sporting club. Capital T is people who play tennis. Capital H is people who play hockey. Clearly, there are people who play both, because there's a number in the middle of the intersection. It says determine the number of people, total number of people in the club. Well, A is going to be 15 plus 27 plus 26 plus 7. Because the 15, 27, and 26 are just the people who play tennis and hockey. there are a lot of other sports in the sporting club, so you have to include the 7 who don't play tennis or hockey. And add these numbers up. Oh, gosh, what is this? 3375, thank you. And part B. How about the number of people who play hockey?
Wait,
26 plus 27.
53.
There are 53 people who play hockey. C. How many people play both? 27. D. People who play neither sport? 7. And E. People who play either sport. Or no, people who play at least one sport. It's not 75. 50. How'd you get 53? At least one sport. If you play 2, don't you still play at least one? Well, if I said you're going to give me at least $1 and you hand me 2, am I happy or sad? Happy. So playing more than 1 still means you play at least 1. So what this means is you're going to include the 15, the 27, and the 26. Now, just because you're in a sporting club doesn't mean you play sports. It just means that you like sports. So it's 75 minus 7, 68. You can make no assumptions. You can only know what is given to you in the Venn diagram. So just because you're in the sporting club doesn't mean, it's like being an FCA, but you're not an athlete, right? Well, I mean, am I right or wrong? I mean, I was in FCA when I was in high school. I got free pizza. I didn't play any sports. I went for the pizza. Mr. Bauman was the sponsor, one of the 2 sponsors. Bauman. He's still here. Tall, thin, brown hair. Anyway, there you go. I don't know what he'd say, history of some sort. When I was here, he was psychology and sociology. There was. We're going to do this last example, but then I want to talk about some other things for you, okay? Other important things. Okay. It says verify. Now check this out. I just showed you this fact on the front of these notes. I showed you that A union B quantity naught is the same thing as saying A naught intersect B naught. So when it says verify it, what they expect you to do is legitimately draw Venn diagrams and shade. And you're going to draw a Venn diagram for the left side and shade. You're going to draw a Venn diagram for the right side and shade, and you'll see that the same stuff is shaded. That's what you're supposed to do. Now I'm going to use highlighters for this one because the highlighters actually blend colors, which is nice. So let me draw my universe. Here's A, here's B. Okay. Let's do some highlighting.
Wait, we draw 2.
Oh my God. On the left side, A union B. A union B would be the entirety of both circles shaded in. But then it says not that. Okay, well, A union B not will be anything that was not in either circle, and that'll look like this. I did my best to draw outside the lines, but hey, you gotta do what you gotta do. If you like coloring in math, take combinatorics. You'll color a lot. Exactly. Now for the next one, what I'm going to do is I'm going to shade A naught. I'm going to shade A naught in blue. So I'm going to make A naught blue, and I'm going to make B naught red. Okay? So A naught is anything that is not in A. So anything not in A. So there's the stuff that is not in A.
Oh, wait, I see it.
Now the stuff that is not in B.
Do we have colors to demonstrate this on a? I don't know. I'll have to be the same color.
B not.
So hopefully you can see that the fuchsia and the purple colored exactly the same thing. That's how you verify that they are the same space.
Wait, how do you verify that they're the same space?
It's the same space shaded, Gavin. On the IB exam, you are not allowed to have colors, unfortunately. You could do zigzaggy lines, which is an easy way of doing it. So either dots and lines or something like that. Yeah, you can just make sure you shade some of them lighter and then where they overlap, make it darker. That's the same idea. Of course, that's kind of hard to do with pen because the IB exam has to be done with pen. So it'd be a little impossible.
Basically what we're doing.
Because it does. Those are the rules. Now, something else I wanted to bring your attention to, because I can't remember if it's going to be in the homework or not, is some Venn diagram style questions, and I'm pretty sure it is in the homework, but I can't remember when we're doing it, so I'm just going to go ahead and say it right now. Let's say it's one of those questions that just says, like how about the tennis and the hockey question? Let me change it real quick. Let me say, so we'll say something like, in a sports club, people have to play tennis, at least one tennis or hockey. Let's just say that. And I say 15 people play tennis. And remember the premise is, to be in this club, you have to play at least one tennis or hockey. 15 play tennis, 17 play hockey, and there are 25 people in the club. How many play both?
It's easy.
Gavin says it's easy. All right, Gavin, what is it?
7.
7. How'd you get that number?
Because 25 minus, 15 plus 17, and then minus 25.
So basically what you did is you looked for how much of an overlap there was, huh?
Yeah.
So all you have to do is say 15 plus 17. That's 32. Well, that means that the 7 got counted twice. So yesterday, that's why I made a point to ask Harris when he was talking about it. He said, oh, we have to make sure you didn't double count it. So clearly our people who play both sports will get double counted if you're not paying attention. But you go, oh yeah, there's 25 people, so the Venn diagram, because then I could ask you questions like, how many, well, I would have to have a third circle, but then I can ask you all kinds of questions that go, well, how many people play just hockey or just tennis? So now I can ask those kinds of questions. So basically you would draw the Venn diagram if it wasn't as easy to just see, especially if there was more than 2 circles, which we will get to. So we have tennis and hockey. So if you had to fill this thing out, then we go, okay, well, 15 plus 17 is 32. 32 minus 25 is 7. So you'd put a 7 there. So how many people play just tennis? 8. Because the circle has to add up to 15. How many people play just hockey? 10, because the circle has to add up to 17. It allows you to answer those kinds of questions. But that's how you fill these things out. Whenever you're filling out Venn diagrams with those kinds of questions, you're trying to work your way from the inside out. You're trying to. That's the most efficient way to do it. And it starts by asking yourself, how many did I overcount by? That should be in the overlap area. Cool? Yes?
And if we're not given the amount that are
If you're not given the amount,
part of either of those,
yeah.
then it just doesn't exist.
Or
it doesn't matter.
Well,
We're not.
Sometimes you can do some algebra. If you have a little bit of information and you need more, you can do some algebra, which we will see happen in the notes in upcoming days. Okay? See, I don't want to spoil the secret, but yeah.
The secret.
Yeah, I don't want to spoil the surprise. How about that?